review for you guys. I feel like there was a lot of questions on the review, especially with the snow thing. Oh, hold up. I was just there. And so we're going to go over this. So first things first is I'm going to teach you guys how to factor. So I'm going to make this a little bit bigger so you can see. 200%, that's nice. Okay. So number one, find the factors. Let me get rid of this. Find the factors of 8x squared minus 8x minus 35. So for this, I'm going to do my X box method. Remember, this is A, B, and C. We multiply A times C, and then we get B at the bottom. Okay? 8 times negative 35, let me get my calculator, is negative 280. Okay? So I'm going to put that at the top. And then I'm going to put my B, which is negative 18 at the bottom. Okay? Now I got to find two factors that multiply up to negative 280 and negative 18. So if you're not familiar, you can always grab your calculator over here. You do y equals, you put what's on top in a fraction. So you do alpha x, put negative 280 on top, and then put x at the bottom. Then do second graph, and then you should get your factors. Note that when you come here to this point, this means that both signs are different and that the bigger number is negative. Okay, so I'm going to scroll and look through my negatives because those are going to be my bigger numbers. And I already know what my factors are, so I'm going to click pretty fast. And it's going to be negative 28 and 10 because negative 28 plus 10 is negative 18. And these two multiply up and equal negative 280. So we're going to put negative 28 here and then 10 here. Okay? After this, we have the starting point of our factors. We're going to do x minus 28. Getting any traction with my mouse. Ridiculous. A lot of drag. And then x plus 10. Okay? We're going to divide both sides by a, which is 8. Okay? And then here we're going to simplify the fractions. So if we're going to simplify both of these, okay? Because we have to work with them simplified. So what I'm going to do is I'm going to do second quit to get here. And if I'm not good at simplifying fractions, it's okay. I don't have to be. I'm going to do alpha x, negative 28 over 8. Enter, and it simplifies it for me. Very good. So this turns into x minus 7 over 2. Okay? Simplify this one, and that is also going to be simplified to x 5 over 4. I'm not going to do that because I already showed you how to simplify a fraction, so I'm going to skip that part for this one. Okay, then here, you're going to take the denominator, which is here, and you're going to multiply it by each term inside the parentheses. So I'm going to take this denominator, which is 2. I'm going to put it here. Then I'm going to apply it to each term. So this will be 2x minus 7 here. I'm going to put this outside the parentheses, and this will be 4x plus 5. So I'm going to do 4x plus 5. And that is how we factor this one. Okay, now if you guys are confused, you can definitely rewind this, watch it again, things like that. But I'm going to erase all this because it's a video, and I'm going to move on to the next one. Okay, Here, find the area of Valerie's garden is represented by the polynomial shown below. Okay, so it's really important. There's really no if and about it. You kind of need to know your perfect squares. You need to know what your squares are. Saying that like what's 8 times 8, 4 times 4, 11 times 11, things like that. You need to know what those equal because it's going to really help speed up the process and be able to recognize things like perfect squares. This is a perfect square because I know that the square root of 121 is 11. Okay? This is telling me that both sides are going to be the same and they're both going to be negative. So I'm going to start setting up the dimensions of my square garden like this because I also know it's a perfect square because it has the word squared in it. These are both going to be minus. The square root of x squared is just going to be x. Okay, so we're going to put x here and x here. The square root of 121 is going to be 11. And that's it. That's all you have to do. If you want to go back and check it, now I'll do that because why not? We can. X times x is x squared. And then x times negative 11 is negative 11. So I'm going to do negative 11x. Same here. Negative 11x. And this last one would be plus 121. Okay? Then this would be x squared minus 22x plus 121. Okay, and that's how you check it. Finding the factors here. So here we'd have to find the factors again. So I'm going to erase all this and I'm going to keep scrolling up. So if you need to rewatch it, you can. All right. So we have this 196n squared minus 28n, and then we have 1 plus 7. These two we have to combine. We have to add them together. So this will be 196n squared minus 28n plus 8. Okay, I multiply these two together, and so here we're going to set up the X box. I apologize, I'm going too fast. And we're going to multiply 196 times 8. And I get 1568. Awesome sauce, 1568. And then I have my B, which is negative 28. So what I had to do is I had to find two numbers that have the same sign and they're going to be negative. Okay, so if I don't know my factors, I'm going to just go up here. I'm going to do y equals. I'm going to clear this. I'm going to do alpha x, 1568 over x. Then I'm going to do second graph. But I'm looking here at what it could be, and there's no way. There's no way that these two numbers can be negative and the app's negative 28. So when you have something like this, you have to know that this is non-factorable. Not everything can be factored. Okay, non-factorable. All right, moving forward. This one is exponent laws. Okay, so you have to know your exponent laws. All right, so what you're going to do is you're going to take this 2 and you're going to apply it to each term. 3 squared is going to be 9. And then this turns to x squared. And then when you have your exponent on the parentheses like this, that means you need to multiply your exponents. So this is going to be y to the 6th power. Same with this exponent. You got to apply it to each term. And then for the square root of 4, you'd have to know it's saying negative 4 times negative 4. But if you're not good with that, just a side note, if you're ever working with negatives as your base number, you need to put it in a parentheses, okay? Because that's how you're going to get an accurate number. It's positive 16. If you just did this, you're going to get a wrong answer because it's actually positive 16. It's not negative 16. The calculator doesn't know everything. So, sorry, excuse me. So some of these things you have to just know. Okay? So, here is going to be 16. Then you multiply your exponents. So it's going to be x to the 4th power. Multiply your exponents again. So it'll be y to the 8th power because 4 times 2 is 8. Then you just leave this last one alone. All right, now you're going to come through and you're going to multiply all your base numbers. So that's 9 times 16 times 2. So you got to multiply all those together. So I'm going to do 9 times 16 times 2, and I get 288. Then you got to add all your exponents, which would be 2, 4, and then this is 1. So you got to add all those, and then those add up to 7. So it'll be x to the 7th power. Then you got to add these, which is 6, 8, and 3. And those add up to 17. And that is what your final answer would be. 288, x to the 7th power, y to the 17th power. Okie dokie, artichokes. Now we're going to be simplifying expressions. Go ask your dad. All right. 35 divided by 7. What's 35 divided by 7? It's 5. So we're going to put 5 up here. Then m to the 3rd power minus m. So when you have your m's on top of each other, that's going to turn to m squared. And then the n's cancel each other out. So you're just left with 5m squared. Sorry, that's an ugly 5, but that's what it is. Now, I'm going to go to k 25 over, and then when you have a negative exponent like this, that means it's going to go to the bottom. So now you got to do 25 minus 5, and then you're going to get 20. So x equals 20. All right, this one is 1/2 square root. And if you have anything that's a half a square root, that means a half an exponent. That means it's going to be a square root. So I'll show you, for example. Hold on, let me erase my previous work. So I have 9 cat ear. Then I'm going to do alpha x to get the fraction 1 over 2. That's basically giving me the square root. So this is 3. And the square root of 9 is 3. So that's what 1/2 is. So I'm going to put 3 here. I'm going to apply it to each term inside the parentheses. Then you got to get half of 4, which is 2. Then you got to get half of negative 2, which is negative 1. And because it's a negative exponent, you're going to put it at the bottom. Okay? Here, we're going to do this, but we're going to do it to each term inside the parentheses. So I'm going to apply it to each one. 2 to the 3rd power is 8. So we're going to put 8 here at the top. Then we got to multiply the exponents, so that's going to be a to the 9th power. Multiply the exponents, b to the 15th power over. Then you do 3 to the third power. So I'm not sure what that is. So I'm going to do 3. It's going to be 27. And 3 times 2 is going to be 6. So it's going to be b to the 6th power. Once I have that, the only thing I have in common left are my b's. So what's 15 minus 6? 15 minus 6 is 9. So now I'm going to have my final answer, which is 8a to the 9th power, b to the 9th power over 27. All right. Sorry. Now, what we're going to do is we're going to do PEMDAS. So we're going to do 3 minus 15 here. So 3 minus 15 is going to be negative 12. And we're going to have k here. So now that these two are together, we can do negative 12k. This is going to be negative 7k. And then we're going to do negative 7 times 14, which is going to be negative 98. So negative 12k minus 7k is going to be negative 19k minus 98. All right. Now, moving forward. Now, this one drove everybody nuts. So I'm going to show you guys how to do prime factorization because that's just the best way to find the greatest common multiple in numbers, okay? And I like to do the ladder method. So what I do is I start with 420, okay? And I find the smallest prime number, and I usually always start with 2. 2 is the smallest prime number, so I always start with there. And then 420 divided by 2 is going to be 210. It's still divisible by 2, so I'm going to put 2 here. It's going to be 105. And now it's not divisible by 2, so I got to find a different prime number. A trick that one of my math teachers taught me was if you add all the numbers and it's divisible by 3, then that whole number is divisible by 3. So we have 105, so I'm going to add 1 plus 5, which is 6. So that makes 105 divisible by 3. So we're going to do this box and 3, and then we got to figure out what 105 divided by 3 is. It is, let me grab my calculator. I'm going to use my one-off camera. It's just faster for me. 105 divided by 3, 35. I should know that, but I don't. It's late. All right. Then we have 35. Now, 3 plus 5 is not divisible by 3 because it's 8. So I got to find something else. But I know this number ends in 5, so I know I can divide it by 5. 35 divided by 5 is 7. And that is the end of my prime numbers. Those are all the prime numbers in 420. Now we're going to do 63. Same thing. We can't divide this by 2, but we can divide it by 3. 63 divided by 3 is 21. Okay? 2 plus 1 is 3, so that means 21 is divisible by 3, which is 7. Now, what you're going to do is you're going to find all the prime numbers that these two big numbers have in common. Okay, I'm going to start here. They have this one has a 3. This one has a 3. Very good. This one has a 7. And this one has a 7. And that's all these two things have in common. So now I had to multiply those two numbers up together. 3 times 7 is going to be 21. So 21 you can divide from 420 and 63. So I'm going to take 21, which is the greatest common number between these two, and p. Now I'm going to put in parentheses. I know that 420 divided by 21 is 20. If you don't believe me, use your calculator. We're going to have p here. And then 63 divided by 21 is 3. So minus 3. And that's how we simplify this expression. Okay. This question here, Helena is closing her flower shop for the day and combining two of the registers in the store. The polynomials below represent the amount of money in each register. Okay, so what we got to do is we're going to combine all the like terms. That's all we need to do. All we're doing is combining like terms. So I'm going to start with this one. I have 16j squared and 3j squared. These are like terms because they're to the same base and to the same power. So we can add them together. So I'm going to grab my calculator, and you can, and you just simply do, here we go, 3 plus alpha x 1 over 6. And you get 19 over 6. So we're going to put 19 over 6 j squared. Now we don't have anything else in common here. Like j, there's nothing we can combine it with. So we're just going to put minus 2 fifths j. And then we're going to add these. These two are like terms, so we can add them together. So I'm going to do alpha x 7 over 5 plus alpha x 3 over 5. And you get 2. So this will be plus 2. All right, and that's it. That's all we do for this one. Okay. Then here is the same process that we did for the first one. Now there's 2 ways to solve this, so I'm going to show you both ways. And I'm going to show you both ways. So one way you can do it, and I'll show you the way I've taught some of you guys, is you can do prime factorization for these. So I have 16 here. 16 divided by 2 is 8. You can also divide this by 2. It'll be 4. Divide this by 2, and it'll be 2. So 16 is comprised of 4 2's. I'm going to do the same thing for 144. 144 divided by 2 is 72. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. And then we have 3 and 3. Okay, so you go here and you circle all the prime numbers that they have in common. A 2 and a 2, a 2 and a 2, a 2 and a 2, a 2 and a 2. So then what you're going to do is you're going to put 2 to the power of 4 because there's 4 2's. That's why I did that. And you get 16. So the number that these both have in common would be 16. So you can pull 16 out, and you would divide 16 from each of these terms. 16 divided by 16 would be 1, and 144 divided by 16, if you put it in your calculator, you would get 9. And then x squared. And that's how this one can be simplified. You can also do a different way. Okay, so I'm going to trash all this, and I'm going to show you a different way to solve it. And the thing about numbers in algebra, there's so many different ways to solve a problem. You really just have to get comfortable with numbers. That's really what you have to do. All right, this is a different squares because these two numbers are perfect squares. I can get the square root of this. I can also get the square root of this. Okay, square root of 16 is, let me not get ahead of myself. It's a difference of squares because we're subtracting in the middle. Okay, so I can have 1 like this and then 1 like this. What is the square root of 16? It is 4, so I'm going to put a 4 here and a 4 here. The square root of 144 is 12. And the square root of x squared is x. But this is not in simplest form. You can factor this even more if you like. Okay? Both of these are divisible by 4. So if I wanted to, I can factor out the 4 and then be left with 1 minus 3x. And this we'd also factor out the 4 and be left with 1 plus 3x. Then you'd go here, you'd multiply these two numbers, and you would get 16. And then we're going to do 1 minus 3x here, 1 plus 3x. And then you would combine these. This looks really ugly. I'm going to do it over here. 1 times 1 is 1, okay? And then 1 times positive 3x is going to be positive 3x. Negative 3x times 1 is going to be negative 3x. And negative 3x times positive 3x is going to be negative 9x squared. These two numbers in the middle cancel each other out. And you're left with 1 minus 9x squared. And don't forget that outside term, which is 16. Now, there's really no simple way of solving this expression. You would have to know both ways. So, I mean, you don't have to know both ways, but you'd have to figure out a way that's comfortable for you to be able to solve something like this. You might get different forms of the answer. You might get this form of the answer, or you might get this form of the answer, or you might get this form of the answer. There's really no way they could shoot anything at you. So you just have to be comfortable with numbers. All right. This last one is a nice breeze compared to that one. You're basically going to subtract the exponents. So x squared minus x, you're just going to be left with x. And negative 49 divided by 7 is going to be negative 7. That's it. Woo! Compared to this long question. All right. And I'm going to leave you with these last ones. This one, a circle has a radius of 3x to the 3rd power, y to the 8th power. The area of the circle can be found using the formula below. What is the area of the circle in square centimeters? So we're going to do the formula, which is pi r squared. This is the radius, so we're going to plug it in for the radius. Pi 3x to the third power y to the eighth power. That is ridiculous, Mrs. Galvan. Sorry. And then we're going to put 2 on the outside. You're going to apply this 2 to each term. 3 squared is going to be 9. And x to the third power is going to be 6. And y to the eighth power is going to be 16. So an answer could be 9 pi x to the 6th power, y to the 16th power. All right, this one, what is the product here? So here we have 3x squared. We have a negative y to the third power, so we got to put that one on the bottom here. And then we leave z at the top. Then I'm going to put this in parentheses. Then we're going to leave this one here, 2xz over 3y squared. So first things first is I'm just going to show you a little shortcut. I have a 3 here and a 3 here. 3 divided by 3 cancels each other out. So I can cancel that out right away. Then I'm going to be left with x squared plus and times x. We add the exponents, so we know that we're going to have x to the third power. Okay. Then we have z and z, so there's 2 z's, so we're going to have z squared. And then we have to leave this 2 in the front because 2 is still there. Over, and then y to the third, so y to the second, it would be y to the fifth. So our answer for this one would be B. All right. This one was the value of x plus c squared. So this one you're just going to have to learn the polynomial laws. So x plus c squared x plus c. So x times x is going to be x squared. And then we're going to do x times c, which is plus cx. This will be plus cx. And then this one would be c squared. Okay, so we're going to be with x squared plus 2cx plus c squared. And our answer would be E. Yay! All right, last question. This one is, what is the value of x? This is a systems of equations. So given the equation below, what is the value of x? So here, we would do distributive property. So this would be 3x, and 3 times 4 is going to be 12, minus 2y equals 5. And then this will be 2y minus 4x equals 8. Now, what I want to do here is the first thing I got to do is I got to get this in the right format. So I'm going to go over here, and it's going to be 3x plus 12 minus 2y equals 5. Taking this and then moving it here. First thing I have to do is I have to move 12 to the other side. So this will be 3x minus 2y equals -7. And then we're going to put this right under it. So we're going to match these. I have -4x here, so I'm going to put -4x here. I have 2y here, so I'm going to put plus 2y equals 8. These two cancel out, and I'm left with -x equals 1. And you divide both sides by -1. And then x equals -1. All right, that's it for tonight, guys. For the extra practice, you guys are going to do that all by your own sum, all by yourself. So make sure you guys get that done. I hope this review helps. I know it's kind of late, but hopefully you can watch it before you take the test. Have a good night, and I will see you guys later.